This video is going to show you the solution to one of the class practice problems, 1511. In the problem, we had three particles, 6 nanocoulombs, a positive 5 nanocoulombs, and negative 3 nanocoulombs. And the goal was to find out what the net force was on the 5 nanocoulomb particle. Notice the NC, that's nanocoulomb, that's 10 to the minus 9 coulombs. First thing I gotta do is figure out directions. So the 6 nanocoulomb and the 5 nanocoulomb are the same sign, both of them are positive, so the 5 nanocoulomb will be pushed away from the 6 nanocoulomb. So it's going to be pushed to the left. That's the force of 6 on 5. The next we'll look at the other charge, and it's a negative 3 nanocoulomb acting on a 5 nanocoulomb. Therefore, the 5 nanocoulomb will be attracted to the negative 3, so that's going to go downwards, and that's the force of negative 3 on 5. At this point, I know what the answer is going to look like. I know it's going to have a horizontal and a vertical component from these two vectors, and the net force is actually going to be the hypotenuse of the little triangle. So there's the net force, and that's where the angle is going to be. But I need some numbers. So to find the size of the numbers, or the lengths of the sides, I'm going to use Coulomb's law. The force of 6 on 5 can be found from K, Q1, Q2 over R squared, where Q are the two charges in question, the 5 and the 6, and the R is the distance between them. So when I put in the numbers as shown, I get 2.996 repeating times 10 to the negative 6 newtons. Now for the other side, I'll use K, QQ over R squared, but notice, even though it's a negative 3 nanocoulombs, I didn't use the negative sign. I dropped the negative sign because I'm only using this formula to find the magnitude of the charge. When I do the math, it gives me an answer of 1.35 times 10 to the negative 5 newtons. So that's great. Now I know the lengths of each side. I still have to find the net force. So let me clear up the screen and make a little bit of room. To find the net force, the length of the net force, the magnitude of it, I'm going to use Pythagorean's theorem, a squared plus b squared equals c squared. Putting in my numbers for the sides of the triangle, I get the F net to be 1.38 times 10 to the negative 5 newtons. To find the angle, I'm going to use trig. Tangent theta is equal to opposite over adjacent, so tangent theta is the length of the opposite side over the adjacent side. Theta comes out to be 77.5 degrees below the horizontal. So there you have it. That's the net force, 1.38 times to the negative 5 newtons, and 77.5 degrees is the direction. So to recap, I found the directions by looking at the particles individually as being attracted or repelled from the particle in question. Then I could make a triangle by summing up the forces and finding the net horizontal and the net vertical. In this case there were only two, so that was easy. Now I need to know the length of the sides of the triangle. So to find the length of the sides of the triangle, I can use Coulomb's law to find how long the triangle is, the length of each side. And then from there, I can use Pythagorean's theorem to figure out the size of the net force, and then trig to find out what the direction is of the net force.